Hello students, today we will talk about the electric field due to uniformly charged thin spherical shell. We know the shell is hollow sphere, so it is like this. This is the hollow sphere. Then we have to calculate the electric field due to a thin uniformly charged spherical shell. Now for this we have to calculate, we have to take the points. So we can take point outside the shell here. We can take the point on the surface of sphere, on the surface of shell, and inside at any point inside the shell. Now if we have to calculate the electric field at outside the cell, suppose that this spherical shell is positively charged and this charge is uniformly distributed over the surface. Suppose that this is Q. Now suppose that this is a center O, and at point P this distance R from the center of spherical shell, we have to calculate the electric field due to this positively charged thin spherical shell at point P. Now for that we draw Gaussian surface. Gaussian surface like this. This is a Gaussian surface. This is a symmetrical Gaussian surface which is enclosing this charge. Now if we apply the Gauss law, as we know that the Gauss law says that phi is equal to Q by epsilon naught. Now Q is the total charge enclosed by the Gaussian surface. This is the Gaussian surface. This is called Gaussian surface. Now this is the Gaussian surface. Now this is the flux phi. So phi is equal to E dot ds. Integration, close integration, E dot ds. Now if we talk about the electric field at point P at fixed distance r, then electric field will be constant. So it will be equal to E integration ds. It will be E integral of ds. So we know that this Gaussian surface is of radius r. So the value of ds will be E into 4 pi r square. Now this is the required flux. Now if we put this value, this equation in Gauss law, so it will be E into 4 pi r square equal to Q upon epsilon naught. So E will be 1 upon 4 pi epsilon naught Q upon r square. So this is the required electric field at point outside the shell. Now suppose that this shell is of radius r, capital R. So this is the electric field at distance r greater than capital R, radius of shell. Now again, if this point P, suppose that comes on the surface of spherical shell. So if this point P comes on the surface of spherical shell, then at distance r equal to r. Now this point has come to here. So again, if you draw a shell here again, now this is the radius r. Now this point P has come on the surface of shell. Again we draw a Gaussian surface near to the surface of shell like this. Now if we calculate the flux will be phi is equal to integration E dot ds. Again this E will be constant at fixed distance r, so it comes out of the integral. So it will be E ds, integration of ds. The value of cos theta will be 0. The theta is 0. The cos theta will be equal to 1. So it is equal to, if we say about phi is equal to E dot ds. So E dot ds will open as E ds cos 0 degree. The angle between E and ds will be 0 degree. So it will be as E ds, integration of E ds. So E ds, the value of ds will be 4 pi capital R square. So it will be equal to E into 4 pi capital R square. So again we put this value in this equation. The total charge enclosed is Q. So it will be E into 4 pi R square equal to Q upon epsilon naught. So E will be equal to 1 upon 4 pi epsilon naught Q upon R square. This is the required electric field due to a shell on the surface of shell. Now again, if we talk about the point P lies inside the cell. Suppose that this is the point P, this is the point, this is center O, this point P here. Again we draw Gaussian surface here. Now the charge is lying on the surface of a sphere uniformly. In this Gaussian surface which I have drawn inside the shell, in this surface the value of charge is 0. The value of charge is 0. So if we talk about the value of charge in this Gaussian surface is 0. So if R is less than R, means the point P lies inside the shell, then R is less than R, the charge Q enclosed by the Gaussian surface is 0. So by the formula phi is equal to Q upon epsilon naught, the value of Q is 0. So the flux will be 0. So it will be E dot ds. E dot ds will be 0. So E dot ds is what? E ds is equal to 0. So the electric field will be 0 inside the shell for R is less than R, capital R.